My name is Ruhi Sarakaya. I am based in Seattle, headquarter one. I'd like to thank Rafa and the team for inviting me over here to meet with you guys. I just want to tell you that the team here in Gdansk is doing a fantastic job. They're building some core components in speech recognition and NLU, and the team is growing here. We are here just to emphasize the fact that there's a lot of good work happening here, and you guys are interested in this space. Hopefully, moving forward, some of you, could join Amazon and help us to solve some of these difficult problems. All right, so let's get started. I actually joined Amazon about a year ago, and I built a team, and the team is named Alexa Brain. And there's a lot of complex technologies in Alexa. So I will try to give a glimpse of what are the problems that we are solving, and what we have shipped so far, and where we are heading in the future. And so the title is Removing Frictions in Natural Language Understanding, Natural Language Interactions with Devices. So before actually getting into the details of what we are specifically doing, I'd like to give you an overview of what's happening in this space, not just in Alexa. There's a lot of energy around machine learning and AI. So I will present my perspective on that first. I will spend more time on that than I should, but I think it is important. So I organized my talk into the following sections. First, I will talk about the frictions. Frictions, this is actually from the customer's perspective. When they're interacting with these digital devices, applications, and services, what are the pain points that they face? I will talk about that. And the frictions about interacting with Alexa, I will give you some use cases. And I will give you an overview of Alexa Brain, the goals, key components, and metrics. Metrics is critical too. When we are a metric-driven organization, we need to measure how we are doing in terms of accuracy, whether we are providing quality experiences to the user, and this is a challenge in itself too. Because if you don't get the metrics right, you're optimizing something for something wrong, and that may not translate to what you want to achieve. And the last part, I like to leave 10, 15 minutes for questions. All right. So this is actually the devices that we launched. I just updated my slide. These are what you see here is we have a new set of Alexa devices. The one at the bottom, they were launched earlier in the year. Echo Dot, Echo Show. Now we have Echo Spot, Echo Plus. So as you see, Amazon is investing heavily in this space, and all of these devices are used. Usage is increasing. They're adopted by the consumers. So this is a strong investment area for Amazon. So let me go back to frictions, actually. I looked up the dictionary, what is friction. So I altered the meaning of the definition of friction somewhat so that it is specific to the technology space interacting with the devices. Friction is actually any variable that is slowing down or entirely halting the progression towards achieving a goal. So here, this probably happened to many of you. Say around Christmas time, you buy a present, and then your kids, family, they open the present, and they see that the battery is missing or some cable is missing, so they can actually use the present. And usually around those times, all the stores are closed. You can't actually get what you need. So these are simple aggravations, that add to anxiety. And the customers usually aren't happy about these things. And this is not just specific to buying stuff. And also, you want to do something on the web. You need to sign up for something. They ask you a lot of information. What you usually the users do is they don't blame themselves. So instead of solving the problem, they usually actually abandon what you have and go seek the solution elsewhere. And according to a latest study, about 78% of the users see these frictions as pain points, and they actually start purchasing something from your service, from your company. And from the customer's perspective, actually, these frictions are a negative customer service. So they don't actually differentiate that. That's a poor customer service from their perspective. And on the positive side, imagine you're going to a website and you're going to go to a business trip and you want to buy a luggage. At the website, you see some suitcases or carry-ons to buy, and it tells you right there that this is actually qualified for carry-on, and you can actually order it right away. And these are positive customer experiences that people actually tell these things to their friends, and that creates this snowball effect. So I was thinking, Amazon is active in many different business segments. AWS, retail, of course, and Alexa. So what does Amazon do? So if you actually summarize this in 2 words, Amazon is in the business of removing friction. And when you think about the one-click shop, it's about removing friction. And Amazon Prime, it's about removing friction. Amazon Go, I don't know, you probably heard about this. This is in Seattle on day 1. It is about removing friction. When you think about Alexa, Alexa is about removing friction. So that is actually the theme. That is the business Amazon is in. And removing friction is key to customer satisfaction. So I will ask you this question, and if you don't get the answer throughout the presentation, you remind me, I will give you the answer. So what is the common thread across these different frictions, different spaces? I like you to think about that. So now, Alexa is in media every day. Actually, there is not a single day that goes by where you hear these news in different news outlets. You may be wondering, what is happening? So I truly believe we are at the cusp of an extraordinary moment in the technology space, similar to that of mid-90s when internet was coming alive. And this revolution is in AI and machine learning. So I will, as I said, I will provide you my perspective on this and try to explain what's happening. The great example of AI is the personal digital assistants. So what is a personal digital assistant? Personal digital assistant is a meta layer of intelligence. So it sits on top of other applications and web services, and it performs a set of actions using those services to fulfill the customer's goal. And it also has natural language interface. This is actually a critical component when we ask the users, do you want to have natural language interface? So this is overwhelmingly, they're preferring this. The reason for that is natural language is the most natural form of communication. It doesn't require anyone to learn anything, any new UI. Everyone speaks the language. So, and intelligent personal assistants rely on a set of core technologies, machine learning, AI, speech recognition, inference, personalization. So there are a set of personal assistants in the market. The Siri was the first one launched in 2011, and Google came a year later, and Cortana around April 2014, and we launched Amazon Echo in 2014, later in November. So I will give an example here. This is a real example. This is a flight card. I was traveling to Prague from Seattle, and I got this on my phone. What it tells me is, my flight is delayed. So there are a set of steps that are happening here. When you think about it, the personal assistant scans my email. Say I made a booking a few weeks ago. It scans my email and extracts all the information, regarding the flight, and it stores it somewhere. And then this is at the day of travel. It computes my current location using the GPS on the phone and checks the traffic conditions from where am I to the airport. And it updates me with this information. And here, my flight was delayed. So it tells me that, your flight is delayed, or, it's time to go to the airport. And also here, what you see, it knows my destination. My destination is actually Prague, and it tells me about the weather in Prague. It even tells me about the exchange rate between US dollar and Czech currency. So these are the things that you probably need to go use 7, 8 applications to acquire this information, and that is a friction. I think the core benefit of personal digital assistants are they're able to stitch these atomic steps, which aren't interesting in itself, and they can provide you value. I think that is the breakthrough that we are facing right now, composing these different set of applications and services to complete a task. That is what's happening with intelligent personal assistants, and that is the breakthrough. And now, just taking a step back, so this slide is telling you basically what happened in the last 50, 60 years. And what you see here is, the computer era started in 60s with the mainframes. And they were in the basement of some large corporations that you didn't know. And then 10, 15 years later, there's mini computers. And 2000s, we have the desktops. And they were in every home. And then we have mobile internet. This is during the last 10 years or so. So these computing cycles are happening every 10 to 15 years. And also on the x-axis, what you see is the installed base. The installed base is also improving by 10x. And the next phase of computing cycle is the Internet of Things. And these are basically any device that has internet connectivity will be a computer. And that's what we are seeing. When you look at the Amazon devices, we're sort of getting into the Internet of the Things. That's the new world that we are getting into. And you will have tens of hundreds of computers in your home. And with this, increase in installed base, also the form factors are getting smaller, the costs are getting lower, and the UI is improving. And so this is actually from Mary Meeker. Mary Meeker is she was ex Wall Street Journal Wall Street analyst, and she's a investor right now. She's very good at predicting the future. And she predicted the mobile internet. She predicted the Internet of the Things. And now I will bombard you with a set of charts. Bear with me. And this is the global computing device shipment in millions. And what you see here is, PCs and notebooks. They're declining flat and declining slightly. That's not good news for Microsoft. And flat tablets are increasing somewhat, but it is the smartphone phones that are running the show, and they're increasing. If you look at the last 7, 8 years, but also it's leveling off, and mobile phones are right now dominating the market. So this is the global digital statistics. So the world population is 7.4 billion, and the people with mobile phone is around 3.8 billion. So about 70% of the world population will have a mobile phone by in a couple of years, by 2020. And when you think about it, the target market for smartphones is anyone, say, over the age of 10. And that's roughly about 5.5 billion people. So in about 2-3 years, the mobile computing cycle is coming to an end, because everyone will have a smartphone. And then, there's no growth. So but the companies like Amazon, Microsoft, Google, Facebook, they need to grow, and they're looking for what is the next big opportunity, not what's the next big thing to invest. And now, this was what's happening with the mobile devices. There's also applications running on these devices. So this is the number of applications in different app stores, iOS, Google Play, and Amazon. As you see, there's no sign of slowing down. This is actually, I think the latest figure is, it's about 10 months old. 2.2 million, 2.2 million apps are in these different app stores. And these are the app downloads in billions. In 2017, it's expected to be 268 billion downloads. As you see, the trajectory is going up. There's no slowing down. And these are the app usage statistics. What you see here is, people are spending more time with the apps, but the number of apps used per month is fairly flat. It is increasing slightly. I just pulled out the new number. This is as of today, actually. Around, people use on average 9 apps per day, and on an average month they use about 30 apps. And as looking at the previous charts, developers are writing more apps, people are downloading more apps, but we are not actually using more apps. It's fairly flat. So this is interesting. And about 80% of these apps are called zombie apps, meaning that no one ever used them. And here is one app, you probably didn't know it existed. It's called P-Times. So this is an app, actually, if you are visiting a movie theater, and you can use this app, and this app tells you what is the best time to pee. And the human annotators, they sit down and watch the movie, and they labeled the movie, between 11th minute and 13th minute, there's no action. So you can safely go pee, you're not missing any action. So the point of this is, there are many applications that aren't providing a lot of value, but on the other hand, there are a lot of applications that is providing a lot of value, but you just don't know about them. And so app discovery, or skill discovery as we call it at Amazon, is a challenge. So that's actually friction number one. This is a core fundamental issue. It's difficult to crack. As I said, there is millions of applications, and they're doing useful things too. So how can you find an app that will help you to solve your problem? That's a challenge. And the other issue is, assume that you found this application that is going to help you to solve your problem. And now you need to learn how this application works. So imagine I gave you a Facebook application, and you actually never used Facebook before in your life. You're going to spend at least a day to understand, figure out the basic functionality of Facebook. And now imagine that you are going to do it for hundreds or thousands of applications. You don't have the time, you don't have the cognitive bandwidth to do it. So this is actually the second friction. This is, again, a fundamental friction, friction number 2. Now, I will ask you a question. So let me see the answer. What is the most valuable asset that you have during a day? Time. You're right. So I will come to what 1,000 minutes is. Now, it's another chart. Here, what you see here is the time that you spend, this is in the United States, the time that you spend on TV, on web browser, and also on your mobile device using applications. The trends that you see here is, the TV time is flat, and web browsing is also flat. And something interesting happened with the mobile devices, and it's going up as you see. Around 2014, the time that you spend on mobile devices using applications surpass the time that you're spending on watching TV. And you also, when you compare the 2014 and 2010, during that past 4 years, you're spending about 2 hours on your mobile devices browsing through certain applications. That's 120 minutes. And as you see, it's going up. There's no sign of slowing down. And so that's what I just said. And these applications are after you and your time. So that's actually what makes them valuable, the user base and how much time you're spending with these applications. Now, I will ask another question. So can you tell me the difference between these two charts? Early Saturday morning? Yeah, 6 years. 6 years. 6 years is the difference. So this is actually how an average US consumer spends their time. 24 hours. You sleep, you work, you care for others, you do home chores. So there is nothing interesting. But looking at the past 6 years, as if nothing has changed. These two charts are the same. And in the previous slide, remember I told you that comparing the last 4 years, you're spending about 2 hours, 120 minutes browsing through the applications on your mobile devices. So where is that 120 minutes coming from? As if nothing has changed in the past 6 years, right? And your 100,000 minutes is actually your daily budget. So if you leave out the sleeping, which is about 7 to 8 hours, that leaves you with about 1,000 minutes. You need to fit everything into this 1,000 minutes. And this is a constraint. This is a constraint. Now, think about I'm giving you the answer. In the very first slide, I asked you a question. What is the common thread across these different frictions? Actually, they all cost you time. You want to get things done, but because of the frictions, you can't. It is taking your time. And that is the common thread. And when you think about it, you have only 1,000 minutes in a day. Even 1 minute is important. Now, given these constraints, like we're using these, where are we using these mobile devices? We are using them when we are having fun, so to speak, when we are meeting with our friends. So the applications are penetrated into anything, everything, anytime, whatever we do. And you have seen these things. They are all too familiar. Maybe some of them. So what this tells you is, you are well over your 1,000 minute budget, and you need help. So you need help. This is actually what Alan Turing says. You need a machine to beat another machine. These machines seems to be a problem for us as humans. And intelligent personal assistants could be that machine that will give you your time back. That is at least the core premise of personal digital assistants. Now, there's another thing happening. This is actually interacting with these devices, personal digital assistants. A natural way to interact with them is voice input. And this is, you can provide information to these devices and services running behind them. If you speak to them, as opposed to typing, the information throughput is 4 times faster. And again, this is all coming down to the same thing that, you go type in stuff and you correct it, and it's taking your time. If you speak to it, and if it works, it's fast, so you're saving time. So this is also a core fundamental, friction. So this is friction number 2, the information throughput to the devices and the services running behind them. And I'm quoting a set of, numbers here. And many companies realize the importance of voice input, so they're pushed deeper into platform in Apple and Windows, Google. So there are a set of predictions here. By 2008, next year, basically, 30% of all interactions will be voice-based, and the word error rate has improved so far thanks to improvements in machine learning. So that created a big drop in word error rate, or big jump in accuracy. Now you will find yourself dictating into any search box. If there's a microphone, it's faster to speak than to type in stuff. And it's because of the improvement in speech recognition, thanks to breakthroughs in deep learning. And the voice usage is, as I said, increasing. Now, answering this question, why big companies invest in personal digital assistants. So collecting all the facts that I said earlier. So every person will have a smartphone in about 2-3 years. And we spend 3 hours a day, and that's increasing, time on the smartphone. And this is actually a smartphone, the notion of the computer is changing. As I said, with the Internet of Things, any device with internet connectivity is a computer. And IoT is happening, and there's no effective, clear way to interact with these devices. So now, just figuring out smartphone is a problem. Now, as I showed in the beginning, Alexa is integrated to your fridge, your stove. So you go, learn the menu, and it's actually you can't. So there should be a clear way. Now you will have, instead of having 3 computers, you will have 30 computers in your home. So how do you interact with them effectively? The UI is critical, and I believe the voice is that UI, because it doesn't require you to learn anything new. You just speak to it, and it should work. And the frictions are application discovery and limited cognitive bandwidth, how these applications work, and information flow to these small form factors and Internet of Things devices. And the constraint is your daily budget is fixed. So Alexa is actually aiming to solve these problems, these frictions that I described, all 3, through machine learning and AI. And this will provide a layer over applications and services running in the back end. Find the right application for your intent, for your goal, and also getting the task completed without you knowing what this application works, what it does. You just speak to your device, and it will find the right application for you. It will complete the task, and you don't need to worry about that. And yeah, so now hopefully all of these things will help you. Is information access, and will help you to get things done, and increasing your bandwidth in terms of time. And this is also expected to be a big growth area, and it's estimated to be $100 billion opportunity. Now, these are sort of big level pictures, and this is my interpretation of what's happening in this space. Now let's come down to Alexa Brain. So Alexa Brain is a collection of initiatives that are targeting to remove the friction number 1 and number 2. And these are, this is basically app discovery or skill discovery, and also hiding the complexity of learning how these applications work. And we want to do it in a principled and scalable way. And these are hard problems to crack. It is not actually trivial. So another thing that you realize is most of these applications are single shot, single turn. You just, Alexa, do something. But then when we communicate with each other, we do back and forth. We have a dialogue, because many things are not inherently single turn. So there is this context that we carry over across different turns to understand your intent, and the machines are lacking in that regard. So understanding context and carrying over different turns and providing the best answer to the user is still an open problem that we like to solve. And adding personalization and memory is important. You interact with Alexa every day. You don't, but we places in other places. And Alexa makes certain mistakes, and it doesn't actually learn fast enough to correct these mistakes. The human nature, we are very repetitive. When we are talking with each other, we are even more repetitive when we are talking with the machines. The things that you do aren't actually dramatically changing. If I observe your behavior for 100 days, look at the 101st, 102nd day, that delta is very small. And yet we are not taking advantage of this repetition. You make the same mistakes. This is another thing that we'd like to look into. Basically, building this memory of what user is doing and making sure that we know what are the problems, what are the friction points, what are the errors, and we correct them. And we do it fast so that we provide more value to the user. And this is something that happens in many companies. I've been to other places. So this is a dilemma. You launched a product, you need to support it, you're underwater, and then someone is coming to you, and I have a better way of solving it, and I'm too busy for that. This doesn't happen in Alexa, and I can tell you that. It doesn't happen at Amazon. It doesn't happen in Alexa. It doesn't happen in Amazon too. The nice thing about Amazon culture is if you think there is a better way to solve a problem. We have our processes writing six pages, basically working back from the customer's problem. This is a friction point. This is how we want to solve it. If you make your case that this is actually possible, Amazon will give you the resources to go chase what you need to do. That's why we are very open to experimentation. We are an innovative company, and there are many examples of this that we can do both at the same time. Now, coming to Alexa. So how Alexa works is, this is an example. So if you ask Alexa, how is the weather? This is actually what's happening. So there is a wake word engine running on the Echo device. So the wake word engine listens for the trigger word Alexa. We also handle computer, I believe, maybe a few other computer, Amazon, and Echo. And as soon as it hears Alexa, then it starts streaming. So this is unlike the perception that Echo isn't listening every day, listening you all the time. It's only listening for the trigger words Alexa. If it doesn't hear Alexa, it doesn't listen to you. Once it hears the word Alexa, it starts streaming the audio. And this audio goes to speech platform. And then speech platform routes the audio to speech recognition service, and speech recognition service is hosting a speech recognition runtime decoder, and speech recognition takes this audio and then spits out the text. This is, many people think that speech recognition is actually about understanding the user's intent. It is not. It is taking the audio, it is generating a set of words. It's mapping the audio to the text, basically, but it has no clue about the meaning of this text. And now, that goes back to a speech platform. Typically, the output of speech recognition is an n-best list. It's not the best decoding of the audio. It's actually, these are the possibilities, say top 5, top 10. So that you want to create this you want to create this ability that some of the downstream components actually can fix these errors, the notional weight binding. If you say that this is what the speech recognition is, you have no way of recovering these errors. But if you say these are the likely candidates, downstream components like NLU and Dialog actually can pick some of the alternates as opposed to top speech recognition hypothesis and improve the accuracy. And then speech platform takes this text and sends it to language understanding service. Again, language understanding service is as a runtime, a decoder, and it's hosting a set of models. And what it does is it extracts the meaning from the text. And what is the user's intent? What are the entities and slots that you find in the utterance? And then that goes back to speech platform again. And this is basically you extracted the user's intent. And now there are a set of skills or services that are registered for this intent. That, if the intent is, check weather, there's a weather skill or weather speech that I can handle that. And this is basically, the skill takes this intent, it says, how is the weather? And, it finds that my current location is Gdansk. And then it provides the weather information and sends that to a speech platform. And with the payload. And speech platform, and also it tells me what is it that I need to speak to the user. And speech platform calls the TTS engine, text-to-speech engine. And then text-to-speech engine takes the text basically, all what needs to be spoken, and synthesizes the voice. That's the Alexa voice, using the speech synthesis Markov language, and it sends that back to speech platform, and that is rendered on the Alexa device. So what you hear is the weather is in Gdansk is, I don't know, maybe 14 degrees and sunny today. So this is what's happening under the hood. All right. So as you know, that we also provide services to third parties. One set of services is Alexa Voice Services. Alexa Voice Services is providing intelligent speech control to any device or product that has connectivity. And you can do things like play music, check weather with your device. These aren't supposed to be Amazon devices. It could be any device. And on the other hand, we have the Ask. I think I realized that there's a talk that's going to talk about Ask. Ask is Alexa Skills Kit. This is about giving ability to anyone, students, engineers, developers, or even enterprises to build skills. Skills that, just like weather is actually a skill, music is a skill. You can build your own skill. That could be, Capital One, for example. They can come and build a skill. You can check your account information. And we provide a set of APIs, tools, code snippets, and documentation so that they can quickly author these skills and deploy to Amazon, Echo, Alexa. And then users can interact with your skill. So you can reach to hundreds of millions of users through this integration to Alexa. So now, this is an example of custom skill. So, Alexa, give me the horoscope for Libra. Again, it's similar to what the flow is similar to what I described for weather. And we get the audio, we do the speech recognition, we understand the user's intent using the models that the developers, actually not the models, the developers, they come and provide the utterances, and these are the utterances that I can handle. It's the intent for them. These are the slots and entities I need to extract. They provide this information. We actually build the models for them. The platform builds the FSTs and statistical models, and we build them. We also deploy them to runtime. And when an audio comes, to Alexa asks horoscope about Libra, and then we go invoke the skill. We have their model, so we run it, and then we also call their skill through AWS Lambda, and we provide an answer to the user. And this is the domain skill. This is actually the first part of the skill. It's not that different. And this is, Alexa, turn on my kitchen light. It goes through the same process. And we can actually call other services here, Nest or other home automation services. Now, as I said, Alexa Brain is about removing the friction. So there is one set of features that's in production right now. This is, let's see. Why I'm not seeing, okay, yeah. This is about suggesting skills to the users. And, Alexa doesn't answer everything. It's expert on certain domains, and we like to, and we are expanding these domains, but the third party is also building these skills, which can handle, answer questions, handle requests for the user. So we want to make sure that they also get a shot at answering the questions. And if you ask Alexa, how can I remove oil stain from my shirt? right now Alexa says, there's a skill called tide stain remover. It can help you with that. Do you want to enable that skill? And the user says yes or no. And the skill is enabled, and you can actually go ask next time, Alexa, how can I ask tide stainer about how to remove the wine stain? It will give you the answer. So we are exposing these skills. If skill isn't, the utterance isn't handled by the first party domains, then we go look at the skills, whether they can provide this answer. And when they do, we ask the user whether they're interested in the skill. We enable those. And then now remember now, we have about 20,000 skills. And they're actually growing every week. I think in February it was 10,000, and now it's 20,000. Now imagine that these third party is contributing to this ecosystem, and the users will get more answers to their questions. We are also building first-party domains, but it's not. We cannot scale to all domains, answering all questions. All right. So now this is a complex problem, as I said. Challenges for natural skill introduction. So let me ask you a question. If you ask Alexa, what should I do for dinner? What do you think the user's intent is? No? User may want to book a restaurant, right? Want to eat out. User might want to order food to the home, or the user is cooking a lot, so they may be asking for a recipe. So you can't really tell what is the user's intent. And now, how about this? This is actually a real pain point. Alexa, find Hunger Games. So the user might be interested in playing music, or playing audiobook, or buying some item, right? You can't really tell. Just going along the same lines. This is obvious, but it is not obvious. Alexa, schedule a package pickup for 6 p.m. Do you think Alexa should hand this over to FedEx, UPS, or DHL? These are skills based on history. Not just history, though. Actually, it depends on it has something to do with it, but at the same time, it depends on the user's location, whether these companies are serving to the user's location. It also depends on the time. Some of the, like FedEx, cutoff hours is 5 p.m. If you're asking this about before 5 p.m., they can handle it. If you're asking 6 p.m., they can handle it. So there is this notion of, real-time information that in order to find the relevant skill, you need to get this real-time information from the skills themselves, because they have the application logic, and we don't control the application logic, and that may change because we don't know. So we should be able to ask these skills, domains, can you handle this request? And when you look at the utterance, this is a FedEx, this is a UPS utterance. They can all sign up for this, but it doesn't mean that they can provide you the answer at this moment, at this location. So this is also another example along those lines. Actually, there are a set of skills that you can use to order food, but it also depends on when you put the order. If it's before 10:30, they take it. If it's after 10:30, they don't. But I think the point I'm making here is this is also, I think David Hardcastle, he may talk about this. Alexa, what is X? Alexa, what is flu? Alexa, what is Amazon Prime? Alexa, what is SARS? And these are when you look at the natural language utterance pattern, there are a set of domains, a set of skills. They sign up for the same pattern. This is my utterance. This is my utterance. But we don't know ahead of the time which of these skills actually provide the best answer. I'm getting to the notion of late binding here. That you can't really determine late binding and context. You can't really determine the user's intent based on the utterance that you see. You need to bring in a lot of context into it. And so the natural language skill introduction, I think I talked about this. So we actually did a study, run a study, 81% of I'm talking about relative skill usage, relative to first-party domains like music and weather, the skill usage is low. And we surveyed a number of people, and 85% of these low skill usage is actually attributed to frictions around skills. Discovery, awareness, they don't know whether there's such a skill. And also once they know the skill, there is this friction around invocation, like interacting with the skill. Right now, the way to interact with them is, Alexa, ask X to do Y. And that's mouthful. Mouthful because users don't remember. Alexa, ask Tide stain remover to clean or remove the oil stain. There's still a lot of friction. I think the natural way to interact with them is, Alexa, how can I remove the oil stain? That is the natural way, just like you interact with the first-party domains. So that is a problem that we need to solve, and we are working on that. I think solving this is critical because what you see here is it will create and turn this flywheel. Flywheel is the customers want better experience. The skills, if they answer questions, if there are more of skills that can answer these questions, that's going to create value for the customer. That's going to make Alexa better. So it will start turning this flywheel. Now, context and contextual carryover. This is actually critical. I'm going to play this just to show the importance of context. Let's see whether it will work. No, it's in another screen. This is not working, so I will skip this demo. So context is, as I said, it's critical. I'm in particular talking about the session context here. So Alexa, how is the weather in Yakima? And Alexa, what are the highly rated restaurants there? And Alexa, how about Chinese? When you look at these utterances in isolation, especially look at the last one. Alexa, how about Chinese? Without context, it can be anything. You really don't know what the user's intent is. But if you have access to session history, you know what the user is talking about. The user is talking about Chinese restaurants in Yakima, Washington. So this problem is you need to carry over the intent and slots across different terms, and these different terms may be from different domains or within the same domain. So an example of slot carryover, Alexa, as I said, that's the example. And, intent carryover is how is the weather in Seattle, and how about this weekend? We give you the weather information. Alexa, how is my schedule? This is calendar. Alexa, how about this weekend? We give you the weather information. And that is wrong. So I think we do it seamlessly. As humans, when I exactly know what you're talking about. But this is a hard problem for the machine. Looking at how about this weekend, if I don't know the context, then I can't really answer this question. So we broke down this problem into slot carryover and intent carryover problem. Slot carryover is carrying over certain entities and slots from previous turn if they're relevant to the current turn. Intent carryover is, the example is, Alexa, how about this weekend? In the first one, you're checking weather. It's still weather intent. In the second one, it's the calendar browsing intent. So you need to be able to figure out the user's intent. You need to be able to carry out all the relevant entities and slots from the previous turn so that you provide the exact answer to the user. The challenge with this is these schemas aren't shared between domains. Say Yakima, Washington is actually weather city slot, Yakima. And then in the case of local search, this is just point of interest or location. These slot types aren't shared. And as a result, when you're carrying over from one turn to the other, you need to know the mappings between them. And we don't have a handle how to solve this problem, especially 3P, third party, they have their own schemas. They don't call the same intents and slots that you name. So this is a hard problem to solve. Now, I will jump to the metrics and measurement. This is actually a critical thing. You measure, you get what you measure. This is the learning I had from people who know what they're doing. So end-to-end metrics is critical for Alexa. Alexa is a complex system. There's many components: wake word, speech recognition, NLU, dialogue, entity resolution. So each of these components have their own metrics that they optimize. The speech recognition optimizes the word error rate. NLU optimizes the intent detection, slot tagging accuracy. But then end-to-end, what is it that the user is seeing? So this is actually what we want to do. Like, I provide an utterance to the user, and it goes through all of these steps that I described. And then user sees an answer. And this answer, you know exactly whether this answer is relevant, it is accurate, or it is wrong. So that's what we should measure. We need to actually abstract away from all the components and measure what the customer is saying. So this effort is, about defining those metrics. So defect rate is that metric. I speak something to Alexa, and this is the TTS output. In the case of Echo Show, this is the card that I'm showing to the user. And can you tell me, on a 1 to 5 scale, whether this thing is perfect, terrible, good, okay, or bad? And the other thing is this side-by-side. This is also an important thing, because we constantly improve Alexa. We update the models, we update the code, we update the CX. Typically, these updates are actually incremental in nature, because you're not overhauling everything. You're updating a model, you're increasing the accuracy. Side-by-side is, if I take my test data that I define and send this test data to the current system and the new system with the updates, and I should be able to get the output from both and ask the user, do you like, for this utterance, do you like the left side or the right side? Again, abstracting away from the complexity. The user, you don't need to be an expert in NLU, you don't need to be an expert in speech recognition. When you see what you're getting, you can tell exactly whether Alexa answered your question or not. This is about telling you the delta between, if the number's showing that the updates has more positives, then it's a positive change what you're making, and you can actually roll that to production. And so having talked all about these, actually there are still high-level technology challenges that we haven't solved. This experience scaling or domain scaling, first-party domain expansion. We have, I don't know exactly the exact number, 20, 30 domains, we have maybe more. But clearly we cannot, the application space I gave you, 2 million applications, roughly take that as a target. We cannot build 2 million applications ourselves. So third party is critical. They should be able to build some of these domains, and building the right tools and infrastructure for them so that they can build these experiences is key. It's not actually solved, it's a tough problem to solve. Local expansion is another one. We don't have Alexa in Polish, for example. Hopefully we will have it sometime. Now you add the language dimension to it. All of a sudden you solved it for English, but now you need to solve it for 100 languages. That's a challenge. And also Alexa is showing up on different endpoints other than Echo devices. Like Wyndham Hotels are putting Alexa in every hotel room. Alexa is on Ford cars. So the endpoints that Alexa is surfacing is also increasing. That is adding another dimension of complexity. And the examples I provided are arbitration among these domains. As I said, the utterance, Alexa, what's X? There are many domains, they raise their hand, this is my utterance. How do we arbitrate between these domains? That's a core problem that we need to solve. And the last one is, as I said, end-to-end measurement. And so this is, more getting into component level problems for speech recognition and NLU, but I should skip that. This is the machine learning team, not Alexa, this is the machine learning part of Alexa. And this is, we are in Seattle, Sunnyvale, Boston, and Europe, and India. And we are hiring. The team here is hiring, developers, scientists, product managers at all levels. So I like to leave some time for questions. Yes.
So we can help you with microphones.
Yeah, maybe that would be good.
I will try to speak a little bit louder. So, what do you think? What answer should receive Alexa, try to ask the Alexa? My life is miserable, I'm unhappy, and what do you propose?
So, my life is miserable. I am happy.
Yes. I'm not happy, nobody loves me,
No one
I
loves
have
me.
enough.
So,
This is one question, and the other, what do you think, how Alexa should react if the customer asks, I would like to commit suicide?
commute?
Suicide.
Commit suicide. Okay, that's interesting. There is actually a set of editorials that we have. These are human-created answers. Oh, sorry. Sorry. There's a set of like for some of these utterances that the users are providing. There is, not necessarily a application or web services that you can call, and some of them are, as you said, it's just personal in nature. We have human editorials that actually human curated answers for these questions. I think the suicide example, I don't know the exact answer, right? We may suggest seeing a doctor or a psychologist or something like that, but there are more funny cases where, Alexa, tell me a joke, Alexa tells you a joke, cheer me up, Alexa does something. There is no, I guess, there is no one answer to these, and some of these are, human-created answers, and so it depends what is the right answer. I don't think there is a right answer for these things. Commit suicide part, I think that one maybe we can, even calling the police for this there are a lot of implications of this. I don't know, whether that's the right thing. At your home, your kids heard that they speak. Police is coming to your home. It's very complicated.
I can also add something to that, to what Ruhi said. So. Indeed, there are, let's say, editorials for this kind of questions, and I know that there were guys. So there was work with the specialists to understand how to answer for this kind of questions to help people. So there was a work with psychologists on that.
Oh, okay.
Okay, can Alexa refuse to answer a question based on the context? For example, if you ask about
Can you put it a little closer? Yeah.
Okay, so you ask about the suicide first, and then you ask for the prices of ropes are out in your area. So can Alexa refuse to answer a question if a context is detected to be dangerous for the user?
Right. So actually, right now, Alexa doesn't give answers to all questions. Sometimes you will hear that, sorry, I don't have an answer for that. Or sometimes you will get the earcon, just a sound, and there's no answer. So we have that with Alexa.
I'm wondering if there is some connotation that it's early morning. I hope not. So coffee is available, okay? It's just saying.
Yeah, I wanted to ask about the whole third-party apps. Is this like a marketplace? Do people pay for this? There's some additional bit, because you said, oh, how do I get oil out of my shirt? Oh, Tide Stain Remover has this.
Yeah.
Now, from the user's perspective, I'm not interested who has the answer. I just want it because I'm asking Alexa. So why do you include this external service? Would you like to use it? Why do you do that instead of just giving me the answer, the best answer?
Right. So the external service, I think the problem is this, as I said, it is about scaling the customer experience. And we cannot possibly build all these experiences ourselves. So that is why we are opening it to third parties, so that they can actually come and build these experiences for the user. That's scaling part, and again, working back from the customers actually doesn't care where they're getting this answer from. It's great if we can answer it first party, but they don't care whether the third party is giving this answer. So I think that's the first part. The other part that you are asking is, the getting into ads and bidding. So we don't have that at Alexa right now. It is we're going after the maximizing the user experience. That there will be a time, probably I can assume, that You want to book a hotel, there are multiple skills that can handle this. Then which one you are going to pick? And it depends on a number of factors, from the skills popularity, from personalization, whether you have used it, again, user's location. There are a lot of factors that are going to get into it to determine what is the best skill for the specific user.
And by the way, for the next talk, we have Max, who will be discussing about third-party skills, so he would be able to discuss the ecosystem. Edita, someone on your side? Okay.
Thank you. I have a question. How do you currently handle user authentication, authorization, and user recognition family?
Family, you said?
In a family, like there are 5 people, 2 parents and 3 kids, or you are in a restaurant and you don't want a neighbor to order for you
Right.
from your card.
So right now there is the customer ID, which is connected to the device right now. We don't distinguish right now. We don't distinguish. There may be 5 people in the home, whether this is the father, this is the mother, these are the kids. It is important to distinguish them, but right now we don't. So let me leave it at that. That's a problem. We know that. We are treating as everyone as a single customer right now.
Okay, sorry guys, last question. We want to try to keep the agenda. So, last one.
Hi. According to this question about suicide,
Come on, it's sunny. It's nice, a nice day.
let's say that I want to know price for some item, and as a joke, I will say that I want to kill myself. And will Alexa know what is my context that I'm joking?
So probably it won't. So that means you're buying something. The first one, I want to buy some shoes. You're in this, okay, what type of shoes you want to buy, and then you say, I want to kill myself. And Alexa, I think, still will ask you what type of shoes you want. So
Thank you very much. Sarcasm is sometimes difficult to detect also for us. So thank you very much. Thank you, Ruhi, for your talk.